Alright guys, this is a pretty interesting problem. I don't necessarily expect you to be able to solve it very easily. So this is, I guess, one of the key ideas in this problem. Yeah, so I was talking about this interesting idea. It's kind of like doing algebra on another level of detail. You know, like you have like a plus b all squared, right? And you can either do it or you can remember what that is. Yeah? So this is kind of like something like that. Okay? It's like kind of like remembering what that is. And this idea, like, I don't know, it's popped up like in this Chinese maths Olympiad as well. It's basically when you look at this expansion. So if I got a plus b times a plus c, yeah? Can you guys tell me what that is? So it's a squared, yeah? Plus ac, yeah? Plus ab plus bc, yeah? Does that make sense? Okay. Now what happens if I, instead of doing a, I put like b plus c and b plus a here? What do I get? Yeah, b squared plus ba plus cb plus ca, yeah? Okay, so then my question is, what is the difference between these two expressions?
One has space, but one has space.
Yeah, and that's the, and the other parts are the same, right? So the difference between these two expressions is very little in some sense, yeah? The difference in these two expressions is just that the squared term here is a, right? And the squared term here is b, okay? Does that make sense? Okay, so, and how does that come up? Well, in this problem, you see, you're given this condition, right? Yes? You want to do something with this condition, okay? But one natural thing to do here, well, I don't know how natural it is, but one sort of thing you can do here is just to clear the denominators, yeah? That makes sense? How would you clear the denominators? So you could clear the denominators, so it's denominator is a plus b, b plus c, and c plus a, right? If you times everything by a plus b, b plus c, and c plus a, yeah? You'll end up with these things, yeah? So that's kind of where it comes up. Yeah, like when you see me do it, it's gonna always look a bit cleaner than what it's gonna be like. Usually you kind of expand everything and it gets all messy and then you're trying to figure out a nice way, right? But if I times this expression by a plus b, b plus c, c plus a, right? So this one already has an a plus b, so the a plus b will cancel. So this will have, okay, we clear the denominators on this one, okay? So you get ab squared, b plus c, c plus a, plus bc squared. Now the b plus c is in this one, so that'll cancel this one. You get just the a plus b times the c plus a. Okay, and then when you times this by the third one, the c plus a will cancel, right? Get a plus b times b plus c, yeah, equals 0. Does that make sense? Okay, and then when we look at these things here, okay, we notice something interesting. So these things here, yeah, they all have like, they all have this AC plus BC plus AB, right? Yeah? That's the same about all of them. Yeah? That makes sense? Okay, and what's not the same about all of them is here there's a C squared, here there's a A squared, and here there's a B squared. Does that make sense? Okay. So what you get is you actually get this thing here. I'll write it in green. So AC plus BC plus AB. So that thing is in all of these, right? So you can write this as AB squared plus BC squared plus CA squared. Yeah? Plus, and now this is the other stuff. So now you have AB squared times C squared, right? Does that make sense? Plus BC squared times A squared. Yeah? And here we have CA squared times B squared, yeah? Does that make sense? Okay, so can anyone tell me anything interesting about these three terms? Okay, so I'm hearing people say some interesting things. What happens if you factorize ABC? Huh? This turns into BC, right? This turns into AC, yeah? And this turns into AB. You see that? Yeah, this thing here, yeah, is the same as this thing here, yeah? Can you see they're the same? So that means it's a common factor, right? So this is like x. This many lots of x plus this many lots of x is just the sum of that lots of x, right? So we get 0 equals AC plus BC plus AB times, we just add this up. Can someone tell me what to write? It's ABC, yeah? Does that make sense? So now I can just erase all this, yeah? Okay, so now I have two things that times together to get 0. What does that mean?
One of them has to be 0.
One of them has to be 0, right? This actually, we just actually used to just say that. Now in school, they actually put a name to this. They call it like the Null Factor Law or something, yeah? But the problem with calling it the Null Factor Law is they want people just to memorize it without understanding why it's true, right? Is it obvious why this is true?
Yeah.
Well, it's because if one of them is not
Something times 0 equals 0.
No, that's the converse of what we want. See, it's not obvious. So just because something times something is 0 doesn't mean when you times the 0 then it has to be that, right? So here, the way to prove this is like if it's not 0, right? 0 is the only thing you can't divide by, right?
Yeah.
So if it's not 0, you can divide by it, yeah? So if this one's not 0 and you can divide by it, then this one is 0. Does that make sense? Yeah? So you just divide both sides. 0 divided by anything is 0. So it's basically just saying you have x, y equals 0, right? If x is not 0, then you can divide by x. Yeah?
If x equals
And
y,
get y.
it's 0.
So worst case, something's non-zero, the other thing has to be 0. Yeah, that's what you prove. So this kind of stuff you can actually prove, and you got to be careful what you're doing. Yeah, so it's 0 times anything is 0, but that doesn't mean that anything times. So this is not always true. Okay, like if you're working in modulo 6, yeah, right? 2 is not equal to 0. Yeah, 3 is not equal to 0. Yeah, but 2 times 3 is equal to 0. You understand? So this kind of stuff when you're doing like, it's like that. Everything else about mod 6 is simpler, but something like this is more complicated. You know what I'm saying? So you gotta be careful what you gotta know what you're doing. Yeah, you can't just like memorize stuff. And does that make sense? So there's a word of caution there. Okay, so what does that mean? So that means either this thing is 0, yeah, or this thing is 0, yeah. Okay, I want us to explore this second option first. We'll call this 2 and this is 1, yeah? Someone tell me what happens if 2 is equal to 0.
Never mind.
You're told they're not 0, yeah? Remember what the actual question's asking you. It's asking you what about this, right? So you might want to try to get that into that form.
A squared C.
What happens, so you got to get these things, right? Like look at this, it's got AB squared. Like, what if you divided both sides by ABC? Okay. So that means this is over ABC and this is over ABC. Does that make sense, Michael?
Yeah.
Alright, so we're dividing both sides by ABC, yeah? Okay, so obviously, like, if you divide 0 by anything, it's 0, right?
So the answer is -1.
Indeed.
Oh,
So maybe, so if you're impatient with me, you can try to figure out what the other case is, yeah? Okay, so if you divide 0 by anything, it's equal to 0, yeah? So this is 0. That make sense?
yeah.
Okay, here we have a fraction divided by a fraction. We can split up the fraction into separate fractions. So it's AB squared on ABC plus BC squared on ABC. Does this make sense? It's like if you got everything over a common denominator, you can just add the top, right?
Yeah.
But here we can also reverse that step and split the top up, yeah? That makes sense? And then ABC on ABC. Okay, maybe you can tell me which one's easiest to work with. Okay, what about one of these things? Can you tell me what AB squared over ABC is? So the top, the A is timesing, yeah? The bottom, the A is timesing, but you can cancel the A's, you understand? Cancel the A, yeah? And then what do you do? So this is like B times B on BC, yeah? Yeah, it's dividing by B, this is timesing by B. You can cancel it, yeah? So, yeah, so then you just get B over C, yeah? Yes? Okay, what about this one? Yeah, exactly, plus C over A, right? Yeah? Okay, so you get this, yeah? I'm gonna erase this. So what do you notice about this now? That equals -1, right? And how's that relevant to our question?
That's thing on the question says.
That's the same as this, yeah? Okay, so what are the possible values of the expression? Well, that's telling you in this case, there's no other possible values but -1, yeah? That makes sense? Okay. Alright, so now we're all on the same page, yeah? So in this case number 2, the possible values is -1, yeah? Actually, logically, it's saying the possible values can't be anything else. We don't actually know -1's possible, yeah? That makes sense? So the impossible values are the non-1 values, yeah? Okay, now, let us look at this other case. So AC plus BC plus AB equals 0, yeah? What do we get in that case? Alright, I'll show you this really cool idea. The reason this is cool because it sticks on the theme, okay? Sometimes it's very cool when this one theme just keeps working. Okay, what would happen if you added plus a squared to both sides? If you added a squared to both sides, you get a squared plus AC plus BC plus AB equals a squared, right? Okay. What was the point of adding a squared to both sides? Is that what you did?
Is it so that side is a plus c times what a plus b, which is a squared.
Yeah. So what does this tell us? So that's pretty cool, right?
Oh, it tells us that a is dividing.
Just think of some values for a, b, and c. Just put in any values.
1.
Something really obvious. It's like super obvious.
Okay.
So what does this mean, yeah? Like imagine if a was like let's say a was, so if a was 10, right? And c was 1 and b was 2, why would that not work? Yeah, so you made a good point. So we can also add b squared. Yeah? And we can also add c squared. Yeah, so we have 3 things, yeah? Well, basically, look, what if c was positive and what if b was positive? What would that mean? If b and c were both positive, what would that mean? Yeah, if c was positive, right? Yeah? Let's just assume they're all positive, yeah? Yeah? If they're all positive, if they're positive, then a plus c is bigger than a, right? Because I'm adding something positive to a, yes? A plus b is bigger than a, right? Because I'm adding something positive to b, right? If something, sorry, to a, if something bigger than a is multiplied by something bigger than a, what would that result be?
A squared. That's bigger than a squared.
It's bigger than a squared, right? Because a squared is a times a, right? If I got something bigger and times it by something bigger, the result should be bigger, right? Does that make sense? So this cannot happen if they're all positive, yeah? Does that make sense? So can you tell me what condition this puts on? What is the only way for this to happen?
Either B or C is negative.
What if they're both negative?
Why can't A be negative?
A can be negative, yeah. A can be negative. So tell me what condition this has, okay? That's your goal for the next 5 minutes. What condition does that put on A, B, and C? So we know they're not. We already know they're not 0. So we don't have to worry about any of them equals 0. So can they all be negative? Alright, so can you see that? So can you see that if C and B are both positive, yeah? Yeah? If they're both positive. It doesn't matter if A is negative or positive, yeah? If they're both positive, they're both sort of decreasing A or increasing A together, yeah? And if it's increased or decreased, it can't equal A squared. You understand? That makes sense? So it's not that. So A can be positive or negative, yeah? But the B and C can't both be the same, yeah? If they're both positive, they both make A go up or down, you know, depending on if A is negative or positive. But as long as it goes up or down, it's not equal. That makes sense? So one of B and C has to be negative. You understand? Okay. So one way to write BC can't be the same sign is you write B times C is negative. Yeah, that's one way to write that. It's not maybe the most standard way to write it, so you can't just write it and expect people to know that's what you mean. But the condition is equivalent to one of them being the opposite sign to the other. Yeah? That makes sense? Okay, what do we do now? You said you could do the same thing with the other things, right?
Oh my day. A, C, B, A.
So what does that give you? Okay, so we said AC is less than 0, right? So one of them has to be positive, one of them has to be negative, yeah? And then what about this one? So AB is less than 0, yeah? So how do we combine these things? How do we combine this, this, and this, yeah? Why is it impossible?
If B is under 0, less than 0, then that must mean A is over 0, but then that must mean C is under 0, and then that must mean BC is over 0.
Yeah, that's a contradiction, right?
So this case is impossible.
Yeah, so there's other ways to say the contradiction. You can say, like, if you add them together, it's less than 0, but this says they're equal to 0, right? Okay, there's many ways to say it. Sometimes, so if they're all less than 0, they can't add up to 0, yeah?
Yes.
They would add to a negative number. So that case cannot work, right?
Yeah.
Okay. Does that mean we're done?
No.
Why not? Prove what?
Negative 1, 1.
Yes, exactly. I planted that, and you seem to have remembered. So we still got to show that it's possible for it to be negative 1, right? Yeah, we just proved it's impossible for it to be anything else. Yeah? So we didn't prove that it was possible for it to be negative 1. How do we make negative 1 come out of this? Alright, so guys, how do we get negative 1 to come out of this expression? I guess the most obvious thing to do is just to sub in values of A, B, and C until that's negative 1, right?
That's a lot.
But there's some obvious values to sub in, don't you think? Yeah, so imagine if you tried numbers that were the same as each other, right? So what if you tried A is equal to 1500, right? B is equal to 1500, and C equals 1500. What happens if you did that?
So positive.
So you get 3, right? You get 1500 over 1500 plus 1500 over 1500 plus 1500 over 1500, yeah? But how can you change it to make it work?
Make A and B negative.
Make both A and B negative. Okay.
Like make two of them negative, so it will be like negative 1.
Okay, that sounds promising. So, if I make A and B negative, yeah, then I get negative 1500 on negative 1500 plus negative 1500 on 1500 plus 1500 on negative 1500. Is that right? Yeah? That makes sense?
Yeah.
And what's that?
Negative 1.
So this is 1, this is negative 1, this is negative 1, right?
1 minus 1 minus 1.
Alright, does that make sense?
Yeah.
That's a pretty cool problem, right? There's like a much harder version of this kind of idea that came up in the China West you can look at. Alright, you guys have any questions about this?